Take one.
Hold up! Progress in science.
Build a wall.
Wait, cut. That's uphold scientific progress, you fools.
I'm sorry.
My mistake.
Whoops.
Take two.
Uphold progress in science.
Tear down the wall.
Tear down that wall.
Tonight, the dirt on dark matter.
There's a problem in the universe. There's something the matter with matter. Our normal matter is stuff made of atoms, like stars, planets, creatures, everything in nature. Scientists figured out how much of this matter there is in the universe by calculating its mass, a scientific form of weight. So it turns out that our atom-based matter, called baryonic matter, is only a small portion of the stuff in the universe. Something like 84% of the matter is invisible dark matter. That's pretty shocking, right? The discovery was repeated over many years, but nobody paid attention. Why, you ask? Here's the story. Astronomers need to know about the mass of heavenly bodies in order to understand the universe. They calculate that mass by observing the spinning galaxies and stars and estimating those velocities. As far back as the 1800s, a few astronomers noticed something weird about their estimates. The mass of galaxies was always greater than the calculations based on the luminous matter, the star clusters they could see, and it was always a big difference. Those few scientists suggested that there was a hidden type of matter, something not observable. In the early 1920s, a British mathematician, James Jeans, suggested that the missing mass might be invisible stars. And the Dutch astronomer, Jacobus Cornelius Kapteyn, went further. He thought it might be some type of mysterious matter. He might have been the first to really think of a unique form of matter. Jump to the early 1930s, and the famous astrophysicist Fitz Zeki of Caltech.
I'm Fitz Zeki. I was what you'd call a character, a polite word for impatient and a little, maybe a lot, impolite. What can I say? I was absolutely brilliant, and I was usually way ahead of the other scientists. But a lot of scientists were slow to keep up, didn't always accept my discoveries. What can I say? I can't be bothered. Anyway, here's one of my best discoveries. In the early 1930s, I was studying galaxies in the Coma cluster especially. At that time, telescopes were really improving, and astronomers were just beginning to realize that the universe was really huge, that there were billions of galaxies beyond our Milky Way galaxy. I was one of the first to calculate the mass of these galaxy clusters. Whoa, and I realized from the velocity of the cluster orbits that the actual mass holding those clusters together had to be several hundred times greater than the figure derived from the observable light of galaxies. Whoa! There was only one explanation. A huge amount of the matter that holds galaxies and galaxy clusters together is invisible. I called it dark matter. It was one of my greatest discoveries. I have been called the father of dark matter, but of course I'm very modest about my huge accomplishment. Hey, this was so important. But did I get the Nobel? No. Did the scientific community notice? No. It was decades before the astronomers understood the importance of dark matter. It was years before scientists realized that most of the matter in the universe is dark matter, invisible stuff that doesn't interact with our normal matter except through gravity.
Poor Fritz. Poor Fritz. Now skip forward some 40 years or so to the 1970s, and another astrophysicist, Vera Roman. Despite her obvious brilliance, Rubin had to struggle for acceptance in the scientific community. She was a pioneer in her field and also a great advocate for women in science.
I was determined to be an astronomer, but in the 1940s and 50s, that was not a field that welcomed females. I wanted to study astronomy at Princeton, but women were not accepted in the graduate program there, so I went to Cornell for my master's and then to Georgetown University for my PhD in astrophysics. Later, I worked as an astrophysicist at the Carnegie Institute in Washington, D.C., studying spiral galaxies. A few scientists in the past had noticed that the visible luminosity of galaxies could not account for the mass of galaxies, but nobody paid much attention. With my colleague Kent Ford, I calculated the rotation of spiral galaxies using a spectrograph. Now, a fundamental law of physics dictates that the rotation at the edge of galaxies should be slower than the rotation at the center. In fact, stars at the edge should sort of spin off. But we found repeatedly that the rotation speeds at the galaxy edge was equal to the speed at the center. This became the galaxy rotation problem. Clearly, there was some sort of mysterious force holding the galaxies together. By the late 1970s, we were able to confirm that galaxies contained disproportionate amounts of dark matter. And that's how I became famous. Confirmation of the existence of dark matter changed the field of astrophysics and the general perspective about the universe.
The 1970s marked the turning point, the moment when astrophysicists really noticed the problem of mysterious dark matter. A prominent American group studying galaxies calculated that dark matter made up not only the bulk of the matter in galaxies and galaxy clusters, but in the universe in general. Jim Peebles, Jerry Ostraker, and Amos Yahil suggested a huge amount of the universe must be dark matter. It took a long time for scientists to recognize this startling fact. Today, there is great interest in dark matter, but scientists cannot identify the source. Dark matter does not interact with our regular matter except through gravity. There are numerous ideas about what it might be. Subatomic particles such as neutrinos and axions, for example, but there are no confirmations. Dark matter is certain, but certainly mysterious.